please welcome our first speaker located in Dartmouth, Nova Scotia, Dr. Mike Parsons.
Great, thanks Eric, and good afternoon everyone. Thanks very much for joining us. I'd just like to pick up on what Eric said briefly there, just to thank again the program management over the last. It's really been excellent from start to finish, and between Gilles and Natalie and all the other folks that have supported the program, they were really key to a successful program over the last program cycle. So I'm just going to give a very superficial overview of our 5-year project on geoenvironmental characteristics of gold and critical metal deposits. So next slide, please. This project consisted of 2 key activities. They were related in that they both had to do with metal mining, but both of them were in very, very different areas and different topics. The first one was the critical metals activity, which was primarily focused on looking at the behavior of elements such as rare earth elements and related critical metals in mineral deposits. We focused on a site just outside of Montreal. And these are things that are very prospective for mining these days, and they're essential to the success of green energy and other technological applications in the future. The second activity was the Northern Baselines activity. This focused primarily on gold mine sites up in the Northwest Territories, and the key focus of that was really to look at the influence of climate warming on the mobility and long-term stability of arsenic primarily in the environment near these mining sites. So, next slide. The project team for the critical metals project consisted of myself here in Dartmouth, Alec Deborah and Jean Percival in Ottawa, as well as Catherine Vanance. And external partners were really crucial to the success of this work, including Heather Jameson and our co-supervised master students Sean DeRoche at Queen's, as well as Tom Al and his student Hannah Balkwill-Tweedy at the University of Ottawa. Next slide. This activity was essentially divided into 3 main parts, and we essentially sort of divided and conquered to look at the different types of waste at this site. So this is the former St. Lawrence columbium mine in Oko, Quebec, about just a 15-20 minute drive outside of Montreal. As you can see, this site consists of 2 flooded pit lakes. There's also a variety of waste rock. There's tailings up on the hills surrounded by that dotted yellow line, as well as some radioactive slag. And the site drains in various directions and surrounded by apple orchards in a very agricultural area. This was mined from 1961 to 1976, and at the time was actually one of the world's second largest niobium producers. Next slide. One of the key activities was really to better understand the mobility of trace elements as well as radionuclides in seepage that was infiltrating through some of these mine wastes, particularly some of the tailings on site. So Alec led this activity and installed a variety of groundwater sampling devices, including piezometers. Also drilled and sampled a monitoring well through the entire depth of the tailings at this site, which had never been done before. The tailings are roughly 25 meters deep. In the drainage, one of the key things he found was fluoride concentrations, which were very, very high, up to 75 times the guideline values for the protection of aquatic life. But in contrast, we knew that these deposits tend to be relatively enriched in uranium and thorium, but really did not see very high concentrations of those elements in the interstitial and drainage waters. While we were doing our project, actually, this site also became the focus of a cleanup plan, and the province of Quebec is trying to actually eventually develop long-term management plans for this site to reduce hazards on site. And so at several times over the last couple of years, they've requested our data and are using that to develop their eventual remediation plans. Next slide. My own work at this site, in collaboration with a variety of different colleagues, focused on the limnology and geochemistry of the pit lakes on site. And again, the key idea was to look at the processes controlling the cycling and release of trace elements in these environments. We actually sampled the pit lakes on 6 different occasions and did detailed water column profiles to look at the seasonal variation, which is very important in these sorts of pit lakes for various elements. And the results show that primarily in the fairly well-oxygenated pit lake waters that these elements are fairly immobile. But once you get deeper down, and particularly in one of these 2 pit lakes, you lose all the oxygen from the water, and in those conditions, including in anoxic groundwater, these elements tend to be much more mobile and can be transported longer distances. Results from this research, again, have been provided to the province, and they're using that to try and actually plan long-term strategies for these two pit lakes. On a technological standpoint, we also successfully measured the concentrations of niobium, thorium, and rare earth elements down to low part per trillion levels using a new Element XR high-resolution ICP-MS at the labs in Ottawa. A really important contribution, and that instrument did exactly what we had hoped it would do. It's very challenging to measure those element concentrations, but we did have success in the last year in doing that. Next slide. The final activity in this project, this particular activity, was looking at the mineralogy of waste rock, tailings, and slag. This involved Catherine and Jean, and as well as our collaborators at Queen's and the University of Ottawa. And just in summary, the tailings were they're dominated by calcite, but contain a wide variety of different phases that host elements like rare earth elements. The slag, which is radioactive at the site, has a very wide variety of very unusual mineralogical phases and glass phases. And one of the things we did manage to establish was that the concentrations of radionuclides exceed Canadian guidelines for present-day disposal of radioactive waste, but have, whereas the tailings themselves have fairly low levels of uranium and thorium. So these studies are just concluding in the next year with these two students. You can see on the slide we set up a variety of leaching tests and have done various measurements on that site. And the slag in particular is one thing that will probably require some active long-term management in the future. Next slide. The second major activity was the Northern Baselines activity. This was led by Jennifer Galloway at GSC Calgary. And Jennifer was very prolific with regards to publishing. She assembled a massive team, including various GSC divisions, lots of university, industry collaborators, but importantly also several First Nations groups that we worked very closely with, not just as in a consultative manner, but actually as partners on this project, including the Yellowknife Dene, the North Slave Métis Alliance, as well as the Tlicho government in the Northwest Territories. Next slide. Jennifer wanted to highlight three key activities, three key results. These were focused in two sites. One aspect of the project took place around the city of Yellowknife, which was formerly a very major gold mining center, and there are various companies trying to develop new mines in the area, but has suffered a lot of legacy arsenic contamination in particular. And our second field site was the Tundra Mine, an abandoned mine, gold mine that was located roughly 300 kilometers up the ice road outside of Yellowknife, that was actually cleaned up during the course of our project, and our results are now being used to help inform the long-term monitoring of that site. Next slide. One of the key results from this project was really, and one of the really most impressive things from my perspective, was the manner in which Jennifer and the team used traditional knowledge and incorporated this with Western-style science. We actually managed to fund 3 traditional knowledge and 1 Inuit, and I will not try and pronounce the word that you can see on the slide. Is basically the equivalent of Inuit traditional knowledge. Jennifer also organized an on-the-land camp with various partners right up in Cambridge Bay in August 2017. And we managed to assemble key observations from these various groups anyways on things like seasonality, their observations on the land, and really the ultimate impacts of climate change on their own activities. Jennifer and her colleague Tim Patterson actually published this last year in Polar Knowledge Canada's online journal in 4 separate languages, providing guidelines for using traditional knowledge in studies of the environmental assessment of metal mines in the north. Next slide.
1 minute left, Mike.
Yep. Thanks, Eric. My own student at Queen's University, Claire Miller, is doing a great job. She's a PhD student there, co-supervised with Heather Jameson, looking at controls on arsenic mobility near the Tundra mine. Long story short here, one of the key results was that we can see very close relationships between the behavior of arsenic and organic matter in these lake systems. And we expect, based on our results, that as the climate continues to warm, some of those lakes where arsenic is associated currently with sulfide phases, we expect arsenic will probably become more stable in the future, whereas other lakes where arsenic is associated with things like iron oxides, we expect may see increased mobility, which will have long-term implications for environmental monitoring. And I think the last activity slide, Eric. Jennifer's also worked a lot on wetlands, which are very, very important in that environment. The wetlands themselves host elements like mercury and arsenic. They are also rapidly changing under a changing climate. And Jennifer's shown that there are 3 distinct types of wetlands, all of which have unique characteristics. And we'll see varying changes as we go forward into the future, which will affect the mobility of these legacy contaminants. So this last slide was basically just a summary of some of the key outputs. You can look at that at your leisure. And I realize this is a very quick presentation. If you'd like to get a hold of me, there's my contact information on the final slide. I'd be pleased to answer any questions you have. Thank you.
Thank you, Mike.